Welcome back, everyone. Houston Math Prep here, doing our second example, integration by partial fractions. So we have the integral of 8x minus 4 over x squared plus 4x minus 12 dx. So I have a single power of x on the top. I have an x square as my highest power on the bottom. So the degree on the bottom is higher than the degree on the top. And the bottom is factorable, so this is a candidate for partial fractions. If you want to check out how we work out step by step how to do this partial fraction example here, you can check out the decomposition in the link that you see. We're going to go ahead and write down what we got from that other video. So if you don't need to see the steps for setting up partial fractions, then you can continue on with us here. We got some fractions for our a and our b. We got 13 halves for one of them, so it ended up being 13 over 2. And then we had x plus 6. And in our second fraction, we had a 3 halves for b, so we had a 3 on top and a 2 down below, and that factor was x minus 2. So if you need details on any of that, go ahead and check that out in the link provided. Now, for each of these, we're going to use u substitution, and it turns out to be just fine. So for the first one, if we let u equal to x plus 6, and du is dx. And this one, we have u equal to x minus 2, and du is equal to dx as well. Then the first one, if I bump the 13 halves out, I end up with 13 halves integral of du over u, which is a log rule. If I bump the 3 halves out for the second one, I get 3 halves, and again, du over u, different u for each of these, right? But that's what we get. We get a log rule for each of them, so these are easy to do. The first one, we get 13 halves, ln of absolute value of u. I'll go ahead and put my u in for this one. So x plus 6 for this one. And then for the second one, plus 3 halves, ln of absolute value of u, which in this case was x minus 2. We'll put our constant of integration, and again, these are pretty short once we've done the partial fraction piece of this. So if you want to see the partial fraction piece of it and how to get this from this, then check out that link we provided. We've got a couple more examples. Some of them have a little bit more complicated stuff in them than just ln for every fraction. Hope to see you in the next one.